Hey, so we're back here. So last episode we started working on what it basically ended up turning into the theoretics of EMPs and kind of how I'm trying to gear the design for them. I realized I need to do a little bit better of a design. So because I'm also thinking about starting to do tutorial videos on software development eventually here, I'm going to turn this into a micro tutorial on design. It also gives me an opportunity to kind of think through what the flip I'm trying to do, because the reality of it is I got a general ideal, and I'm more aesthetically focused on the fact I got into a school that I'm so happy that I don't have to do anything. So we're going to take a moment and actually focus on the design. And if I can catch my breath here too, I was just spending the last few minutes here playing with my dog, and she's all happy as well. So she's been feeling better, so I was like, oh, I should make up for the last 2 days of not playing with her much and actually go play with her. So when it comes to design, the first thing, make sure you have somewhere to put your designs. Don't put them in a notebook. Even though notebooks are amazing, you lose them, you forget about them, you don't look at them. You want to put them somewhere where you're going to access them. You want to put them somewhere where they're safe. So I always recommend Google Drive, Dropbox, some kind of secure system. I mean, I know they're not 100% secure, as in somebody can just open your Dropbox and take your stuff or delete it or whatever. But they give you a place that if your computer failed or you couldn't access your computer, you can get to your designs. They're in a good spot. With Build Broken, we actually have entire drive that's shared with the entire team, as well as anybody else we just feel needs access to it. We store everything in here. We store transcripts, tax information. The tax information actually is not related to this. This actually needs to go back in my folder back here. But so we keep a lot of stuff in here. We keep software plans we're working on. We keep TeamSpeak log info, various things. We do video scripts in here. We haven't actually made a proper video with a script before, but I'm sitting here writing a ton of them, trying to make sure I get my ideals forward and plan for scripts and stuff. Of course, we do various things. Like we have a folder for Skyrim, we have a folder for Minecraft, we have sites, logos, libraries. I'm actually probably going to make a new folder called Modding and throw everything in there, because this is the folder used by both my studio and BuiltBrokenModding gaming. I actually need to start separating the two out, because when I actually LLC both of these companies, I need to make sure they're entirely separated from each other, because there's like a weird set of laws and restrictions I've heard of. I haven't read them, I've just heard they exist, that you're not supposed to share stuff freely between two companies without proper frameworks to do it. So you can share information with each other, but you have to have this setup that goes, okay, this information is owned by this company, this information is owned by this company, this IP belongs here and there, etc. So that way you don't fuck yourself. I have a library of books, everything else, but I do. Well, actually, it's not what I'm looking for. This is actually not related to the industry either. I need to clean these folders up. Another important tip about designing: make sure you actually organize. So we have a folder for Minecraft in here. We got tons of stuff in here. We got basically request folder for things. We've got screenshots of different various things, like stuff like that. We've got training materials that we're trying to build up. This is policies and stuff. These are for employees. I'm actually going to probably show those. This will probably become public information eventually. That is for the gaming side. The modding side, we'll probably only share half of them. In the studio, I'm not sharing any of them, because it's a security problem to share policies. If you ever make an organization, just remember, share stuff that you feel safe that everybody should know. Don't just give away everything, because you'll break your own security information and stuff. I just took a class on that's the reason why I mentioned it. So what I want to really look at in here, so I don't get off track and start rambling about something else, is we want to look at, of course, I want to say we can open up the ICBM folder, but this is now a Volts Engine thing. So we're going to make a document, and actually we're going to make a link here. We're going to call it EMP. So we kind of keep everything separate, because I'm going to make a few things here. So when I'm designing something, the very first thing you want to probably do is just make some kind of thing in here. I'm going to do text documents because I'm lazy. So this is going to be the specification. We're going to call it the spec because I can't spell. So when you design software, you design anything, the very first step you want to do is figure out what it is you want. So we want an EMP. So the goal is EMP that does what? So we just know our goal. So the goal is EMP, is to make an EMP. Actually, it's to convert the ICBM EMP into a reusable and functional mirror of real EMP logic, actually, since I can't spell behavior. So that's our goal. We want to convert the ICBM EMP into something that's reusable. So right now, the current version uses a simple breadth, I think is how you spell breadth, first pathfinder to find tiles and remove energy. That's literally what the current version does. There's nothing special to it. It just removes energy using the universal energy framework. So that's what the current version does. The version we want, so the new version, we want to find tiles in a fast, efficient way, determine power of EMP based on distance, material passed through, implement API to handle action. This is what we did in the last episode, was handle actions. So what else do we want to do? So we want to implement API and logic to handle weakening the EMP. So one of the reasons why the original EMP path found is that there was a plan to make materials that could block the EMP. Now, I still want to do this, but I've changed my thought process on how it works. So with the original version is that it path found anywhere. So this means it could take right hand turns. A real EMP really can't do that. It can't turn. It can get deflected and refractors and stuff. So it's something that we can do with that, but that'd be definitely something we do later. What it's primarily designed for is it can just spread out. So an EMP spreads out and hits all the tiles in the way. So I've kind of explained this with how I want everything to work. And unfortunately, my dog is barking at me, so I'm going to short pause, figure out what she wants, because apparently playing with her for a few minutes was not enough. I'm going to say she probably wants fed, but I'll be back, and I'll show you what I'm talking about here. Maybe I'll doodle it before I start the next frame up. Okay, we're back here, and the dog has been pacified by feeding her her favorite food, which I still question if it's food. It's like that canned stuff, and it doesn't smell great, but it supposedly is more nutritious than half the stuff I eat. Anyway, so I do doodle really quickly a little thing here. I know it's not perfect, but it should get my point across here. So when an EMP goes off, it doesn't just hit everything in the circle with the same amount of power as it travels through objects. So as the wave travels through objects, so just to iterate on what a wave is, because I really need to think this through more when we do this. So we'll get a wave here. So like you have an energy wave that comes out, it's like this, it comes out. When it hits an object, it doesn't necessarily keep going through. It actually kind of a little bit weakens. So it'll kind of like wrap a little bit around this, and then it will still go through the object, but it'll go through the object in a much weakened state. So it doesn't just keep going with the same amount of power. And that's something I want to emphasize with the EMPs. I want them to have a conceptual understanding of what's going on around them in the environment. This is what the drawings decided to do. So everywhere in the blue, any of these boxes which are representing machines get hit with about the same amount of power per distance traveled. So like at this point, this guy gets with 5 watts of power, this guy gets hit with 3, this guy gets hit with 3, this guy gets hit with nothing because he's so far outside the range he lost all power. But when the wave travels through, say, like dirt, for example, instead of this guy getting hit with that 3, like this guy got hit with, maybe gets hit by 1 watt of power. This one who's behind a stone wall gets hit with nothing because not only is outside the circle, but ignoring the fact, assume the circle went out further, the stone wall absorbed all the energy. This is very much does sort of work this way. Electromagnetic signals will go through stone walls, but they don't go through stone walls very well. You can know this if you're in a big stone building, your cell phone stops working. That's kind of the same ideal, is that there are things in the environment that can absorb energy. And they absorb all kinds of energy. They don't just absorb heat, they don't just absorb sound, they can absorb electromagnetic energy. Metal objects are great at this. If you put a metal object between you and an EMP, it'll suck up most energy. This is where the idea of the Faraday cage comes from. Although do be warned, if you're close enough to the EMP going off and you're in a Faraday cage, it turns into a lightning box and you can just shock yourself to death. This is another thing I want the EMPs to do, is if they hit a metal object close enough, they're going to generate lightning. So you'll have like little lightning effects coming off. I need a color that I can paint with. Little lightning effects. Should paint in this more often. This actually is not too bad. But yeah, this is the ideal I want to get across, is that you will have this. And the way I plan to make this work is that from the middle here, you will have a line of sight check that goes to the middle of the tile. And it will go, okay, for every object that I pass through, how much energy do I lose? And it'll go, okay, I passed through a block of dirt. I lost 1 watt of energy. I passed through a block of stone. I lost 5 watts of energy. And it might not even be just a single value. It may be percentile based on the strength of the energy blast and a few other things. And there'll be a whole bunch of physics I'll put into it. For the moment, I'm just going to be really simplistic with it. For every block of we pass through, we lose 1 watt, unless it's like special case. Like I'm going to go, okay, metal blocks suck up like 10%. And what this will also do with the API, so like the specifications we were talking about here, if we have a block we pass through that has a certain interface applied to it, we now can control how much power we lose. So say somebody makes a block that absorbs 10% of the energy no matter what it is going through. So if I had 100 watts, I now have 90 watts after I pass through that object. So it sucked up 10%, 10 watts. If it was 5 watts I was going through there, I just lost 0.5 energy. So I'm down to 4.5 energy going through that. And that's how that would end up working. Of course, it'll be a lot more logic, and hopefully somebody won't cheap out like that. But I can see mod packs wanting to do simplistic things, especially for like ICBM Classic. It's meant to be simplistic. But the ICBM, I'm hoping people actually make pretty realistic mods for it. After all, that's what it's geared towards. So we got our specifications kind of. I mean, if we were doing a proper specification for design, this would be like 15 pages long for something as simple as this. Because we would go through every different thing. We would go, okay, this will have an API that does something. By the way, when it comes to designs, for specification for software, will is something that should happen. Or will is something that must be in the final version. Then you can have should, which is optional. Actually, I think more quickly. Will is something that's required. Should is something that's highly advised, if I remember correctly. So it's like it should ray cast each block and check for API handling, and then can do additional checks based on block type and material. So how it works when you're designing a document and you're creating it, you go, okay, will be something that's absolutely has to be in there. Should is something that must be considered and put in there, and then can is something you can do if you have time, but we really don't care. It's something that really should be considered. And that's just an example. I mean, somebody's going to find this document here later. I'm going to find it and go like, what are we talking about here? We got all this different stuff. It doesn't follow specifications at all. I'm just trying to give you guys an example because a real specification doc takes hours to make. There's a lot of consideration, back and forth talk, and you do a whole bunch of things. We're not at that point, and I definitely don't have the patience to sit there and do that right now. The next thing we want to do with this, by the way, is what I was originally imagining when I was going to make this, is that we were going to do a couple drawings to explain how things are going to interact with each other. There's a lot of design work when it comes into designing things, because you have a specification document, you have the requirements document. So specification is just what you want in there. Requirements is kind of similar, but a little bit more detailed. Then you have an implementation document, is like how you're actually going to do it. There's a whole bunch of things. I don't do these documents normally, so don't assume I do this all the time. I've only been taught them in college, and I've been told the only time I'll ever see them is in a big project. Most of my freelancing stuff, the closest I'll ever get is a specification doc for freelancing. I won't even really get a requirements doc either. So we just go, okay, here's what the client wants, and that's about it. And we don't really even talk about implementation much. We just go, okay, this is what might happen, might not happen, and we just kind of talk it out. What I was going to do here, if I can get out of the ICBM folder, is go to here, because in order to use most of the tools for Google Docs, you have to actually be on the web interface. And I want to do a Google drawing. And this is probably not the most ideal place to, you know what, actually, screw using a Google drawing. I have a better idea. I have professional software on my computer. Let's do the professional software. Now, I know most of you guys won't have this. There's tons of alternatives to this. And to be honest, I kind of find Physio shitty most days. But I want to do this little thing. And I want to use... yeah, let's use a colorful one. Now let's do metric. I like metric. I may be from the US, but metric is awesome. Well, you put a whole bunch of things in my document I didn't want. So, ignoring what this is, basically, these are used to kind of describe how your interactions are going to happen and how things are going to be handled. I'm not going to use it properly. So don't sit here and go, okay, this is how you do a UML class diagram, because I'm not going to do it properly because I don't care. I find a lot of the UML stuff, which is designed for creating these things, to be garbage. They're cool, they're useful, they're not human readable whatsoever. If I hand this to a designer, if I hand this to like my model maker, they have no clue what's going on. Like, I would have to explain everything to you. Like, for example, these little numbers here tell you how many objects are attached to each other. Like, if I make an object, how many sub objects does it have? There's like relationships and everything else, and they're not, they're useless is a good way to put them. And goodbye. What we're going to have is, so we're going to have the EMP, and the EMP is going to, of course, be something. I need to get rid of all this garbage. Goodbye, goodbye, goodbye. So the EMP is going to have a location. It's going to have a power value. And that's it. We really don't need anything else from the EMP. That's the only two pieces of information the EMP cares about. Now, what it's actually going to do, so it's going to perform some kind of action. So it's going to perform a tile locator. Tile. And I need another diagram to go with this. There's multiple different diagrams that handle this type of behavior. So what we would have, collect tiles is what this would actually be. And you would have tiles. So you have a tile. So the tile would have a location. It'll have EMP properties. And that's it. That's the only thing we care about, the tiles. We don't care about anything else. So we got that. So once we get all this up, we want to then do things. So we want to go, okay, we're only going to have, we'll have one EMP to every tile, but we're going to have one or more tiles. So if an EMP, actually, we could have 0 more. There could be a time when an EMP goes off that you don't do squat. So you're going to have tiles. You're going to have subversions of each of these two, by the way. So I need another one of these guys. So you're going to have impeders? I think that's what I'm looking for. I'm looking for something that means to impede. Impede, free dictionary, to retard or obstruct. I like how the word retard is used. Impede tiles. What to call this? Damage tiles? So with this you would have resistance. Oh, I like how you just didn't at all do anything I wanted you to do. So with the impede tiles, we would have a resistance and we have a path. So we would know where this came from. How did this chain into our path to get to our tile? They would have, we have a result, because damage tiles you're not going to really do anything with. At least I can't think of what else you would do with these. And these would be, technically these would be inherited. Can I think I have to use the connection tool for this. Inherited. Oh yeah, you didn't at all try. This is why I said Visio is like not the best software for this, because the reality of it is it's not user friendly. That's not what I wanted. I want you to connect. Okay, we're just gonna do this. So we would have a tile. We have two subdivisions. We have a version where this is what we want to damage, and we have a version this is our impeding objects. And what would happen is we would pathfind to get this. So the fact is we wouldn't actually collect a list of impeding tiles. We would just have a list of damage tiles, and we would path from each of those damage tiles. I'm just going to go ahead and save this. So this would be save as. Man, this is why I don't like Windows products anymore. Is that they try to convince you to use your OneDrive stuff and your emails accounts, and I don't want to use any of those files. Can I add a place? Oh no, you have to add a SharePoint or a OneDrive. So it forces you to browse on your computer, but it tries to encourage you to use the OneDrive stuff. And that's the reason why you'll find me use Google's products all the time, because Google doesn't care. Google's like, I just save it wherever you want to save it. We don't really, it doesn't matter. Actually, can I get to... Should be designs? Nope. Production. Yes, I got to where I wanted to go. I knew I had a bookmark. So this would be data types is what I'm going to call this because it's worthless. The thing I actually want to make on this, and I did one of these, I did actually like 30 of these a couple days ago for a class, is a sequence diagram. I think is what I want. And we could use a sequence diagram. So what we want is software. This is all the software stuff. Like you can do wireframes. Wireframes are really nice, by the way. If you're ever designing GUI software, wireframes are your friend because they help you comprehend what you want to do before you even try. Wow, they got tons of. There's a data flow diagram. That's not what I want. Data model. Technically, I could use one of those. UML's database notation, Chin's database notation. There's a lot of database notations. I've never actually sat here and looked at this. This is what I'm looking for, but I'm trying to think of like what is a better way to do this. And I could do a UML activity or a UML state machine. Let's just do a UML activity. That'll work. So the reason I'm doing this, by the way, is I'm trying to get in the habit of planning things out. So it is very often I will not design anything when I make something, and it leaves a huge gap in knowledge and understanding when I'm done making it. So I'll make something, I know exactly how I want it to make it. I'll go and make it. It'll be perfect. It'll be fine. I'll come back 2 weeks later and I'll go, what was I thinking when I made this? And I have no clue. And I'll go, okay, I have to then reverse engineer my own code. Making design documents helps with this. And I actually have never used an activity before. So we'd have an action. So we'd have an action like EMP going off, EMP trigger. So we want to do a few different things. So we got a decision node, by the way. So we'll have something like do. Yeah, this is like horrible. So you have like an action you go do. Okay, so now you want to do is path tiles. It's literally what it's actually, I think, called in the pathfinding code. So you path tiles, and then we want to go okay. So do action. So EMP trigger. That's a start point. Is there a connector? Yes, there's a connector. And you have arrows. Cool. You are useful. So we want to path tiles. Path tiles is then going to collect tiles, and this is going to actually do some other things. So collect tiles actually goes off to, we're going to do this off to the side. This is not the way that you make these. I honestly, I'm not sure what an activity diagram. I've probably made these before, but I was going to do a sequence diagram, but the reality is sequence diagrams are not useful for this application because sequence diagram is, it shows you their interactions between multiple components. So say if I wanted to know, okay, how the EMP react with some kind of radio wave signal and how the radio wave signal interact with a map, how the map interact with the chunk saving system, how that interact with the network. I can show all the interactions and it'll be really useful. But with this one, we only want to show the path of logic and the steps needed to require. So collect tiles, we want to, okay, access the tile system. So tile caches, I think is what I'm going to call it. So we want to go, hey, we're going to access tile cache. We want to go, okay, get our data from our tile cache. Tile cache is then going to give us our stuff back. Stuff like that. So it's get tiles. So we'll do this. Get tiles, and this is going to, of course, map back up to here. So we're going to go back into that. So we get tiles, go back on the collection tiles. We want to sort them. So we're going to figure out, okay, we're going to call it filtering. So we're going to filter out any tiles that we don't care about. You don't want to just map over every tile. Then we want to go, okay, for each, we want to path to each one. And this is going to be a ray trace pather, is what the ideal is. So we'll go ahead and do this. So we get a for each ray trace path. And then we want to go, okay, for each block. Actually, this will be for each. For each tile. Then we want to kind of, yeah, this is not ideal for what I'm trying to do. So we want to make some kind of action. So path to or we're going to go ray trace. And then we would go, okay, for each block, and I need to change my cursor to pointer. For each block, then we want to go weaken signal. This stuff is probably boring to you guys. You might learn something. Who knows? If you guys like this format, you guys can comment down into the comments going, yeah, this is cool. I do want to do more of these. Not necessarily design ones because, but I plan to do tutorials here eventually. I've even thinking about doing a live stream system where I get on like once a week and I teach people how to program. And I want to start with the basics and go through things, so I'm going to try to warm up with doing videos because I got to figure out like how am I going to teach this material. There's a lot of knowledge when it comes to software design and very little time to teach it all because I've been learning it over 4 years almost, and I want to compress that 4 years of knowledge into maybe a month or two worth of learning is the ideal. Anyway, so for each tile, we want to go through and raycast. We then want to go for each block found, weaken signal, and then once we do all that, come back here, damage tile. So we want to hit the tile, we want to damage it, and then that's it. We're done. So we then want to go to our exit. So final node. Well, actually, technically, this would loop for a while. So let me do a connector here. Loop. Go pull this back on the side so it doesn't waste paper. I'm not going to print this out, but I mean, always want to design these. So technically there'll be logic here. So we go do path tile, get tiles, etc. So it gives you logic. It's really simple. What the ideal would be is right around here, which I'm going to actually use a couple of nodes to pick this, is I can put this here and I can scale this guy. So can I put this guy behind things? Can you go to the... yeah, that's how you break your things. So at this point, what we're doing here is we're trying to get all of our tiles in range. Then once we find all of our tiles in range, this is just the action part. So this is just we want to commence our action. I'm going to put like all these right here so that depicts what we're doing. So this is our actual action state. This is our collection state. So everything is above at this point is a collection state. Can we draw lines on here? Yes, we can. Can I draw a line? Yes, that's cool. Nope, I cannot draw lines. How do you do this? It gives you the line ability. Or can I change the color edge of these guys? I can. It's not very useful, but what I can actually do is come over here and change the fill color. That's actually useful. So that helps visualize what I'm talking about. So this is our collection state, this is our action state, and this guy is just our overall effect, which will change the purple. So EMP triggers, get all tiles, and then for each tile we want to trace to it, and we're good. So I'm going to go ahead and save this guy as well, and watch I have to go find everything again. So yeah, it doesn't even store where your last location is. I almost want to do a software review of Microsoft products, but the last thing I want to do is piss those guys off because all the power. So logic is what we're going to call this one. And this is kind of what I want to show. I wanted to show just what the logic was about right before I go and make it. So we're going to do this, we're going to make it in the next video, and this is just really short. Me rambling on about design and attempting to teach something, because the reality, I don't think I taught anything in here. I'm going to have to probably make a scripted video for this and actually go over everything. But the general idea is what you want to do when designing things. Don't worry about the actual design process itself. When you design something, the most important thing you want to do is just get the ideal down. Get it down into a format that is humanly readable and recognizable. This is the reason why I try to use formats like this. It's somewhat human readable. It's not recognizable because, of course, if you don't know what I was talking about in each one of these regards, it's not very useful. A better way to do this would actually be a descriptive going, okay, we start with the EMP trigger, we go to pathing tiles, we collect the tiles, everything else, which actually we could go to spec here. And we can make a thing called process. So we go trigger EMP for size and power. Get all tiles within the range of the EMP. Filter, and these would be numbered, by the way. So you go trigger EMP, so this would be 1. Actually, this would be 0 step because that's your initialization. Then 1 would be get all tiles. 2 would be to filter to tiles that can be affected by EMP. 3 for each tile found, path. And this is where the tricky part too is. I'm thinking about this is that you're gonna have to create a state machine for this, some kind of state system, because what happens if you have 3 machines behind each other and you're all trying to EMP all 3 machines? Do you repeat the calculations on all 3 of the tiles, or do you start trying to be logical about it? Do you try to figure out things to do? So we go for each path towards target affecting tiles along path. So you want to path towards target, and while you're doing this, record tiles pathed, weaken power per path tile, do EMP effects on tiles contained in list that were pathed during process, remove tiles pathed to avoid duplications. So that's the part I was thinking about. Is these are things why you design for things. You want to look for issues like that. Then once you do all that, move process actions and dump to world handler. So this is a threaded action, by the way. So world action, do not do actions on thread. So you don't want to do any of your actions on the thread. You want to dump them to the world handler. The world handler will actually do everything for you. So this is pretty much a 4-step process. So it's actually, yeah, 4 steps. So get all tiles, filter tiles, path all tiles, and then dump to process. And this is actually an exit condition. So this is kind of your exit, and this is your start. And there's your process. So I have that documented down. I know how that works. And if somebody comes in here and they want to figure out how the EMP works, it's documented. It's actually in a place. But yeah, we'll go ahead and close this out. So next video, we'll actually start on the process of making this.